All right, so this is our net change, which is nothing new. We've seen this before. And if you solve it now, we add the f of a over here. What we get is f of b equals f of a plus the integral of a to b of f prime of x dx. So all we're doing is solve this equation, and we're getting a total cost function. And I'll explain why we need to do this. Why is net change not the total cost with an example? So we have the marginal cost of producing a certain commodity is this, and it's dollars per unit, right? So it's our derivative. So what it's saying is if you plugged in Q, it would tell the dollars per unit to produce that next unit, right? That's what we used it for as an approximation. So I've already graphed it here with our nice Riemann sums below. And so if you plugged in 0, we're expecting a cost of $1 for the first unit. And if you plug in 1, well, we're expecting a cost of $7 for the second unit, and 13 for the third, 19 for the fourth, 25 for the fifth, 31 for the sixth, and so on. So if we take this function and we take the integral as n approaches infinity, it tells us our total cost. So from 0 to 20, the total cost would be the area underneath this curve. And so that's why we're getting this. This is just our normal integral, and you plug in b and you plug in a, and it tells us the total cost. We also knew that from before when we did total cost. So I'm going to put it all together in one problem. We're going to do a bunch of parts here to kind of see the connection between everything. So let's start with the first one. It says, what is the total cost of producing the first 100 units if the startup costs are $100? So like we talked before, this does not include the initial cost. What it's telling us is how much does it cost from 0 to make 1? Well, if 0 already had a value, then we have to add that in. So what we end up with is this. Our cost of, let's actually do the integral and then we'll solve it. I'll show you what I'm talking about. So the integral from 0 to 100, that's the net change in cost of c prime of x dx. And so what this would become is c of 100 minus c of 0. So you can see that is the cost for the first 100 units. So if we rearrange this, we get c of 100 equals the, what we're going to do is just add c of 0 to the other side, plus the integral from 0 to 100 of c prime of x dx. So see, if they had asked what is the change in cost from 0 to 100, then you would just use the integral. But we want to know what the cost of 100 is, so we have to include the initial cost as well. And then it's a quick integral. So we get 10,000 for our C0. See, that's what this is. Initial costs are C0, C of 0. And then minus plus integral 0 to 100, and then we plug in our marginal cost. dq, because it's a q, so we have to use a q. Okay. So now all we have to do is plug this in our integral to see plug this in our calculator to see what our answer would be, or you can do it by hand. So we get $40,100. So that would be the total cost of producing the first 100 units. So now let's make the question a little interesting. What is the total cost of producing the next 100 units? Well, on this one, we're not including the initial amount. The C0 doesn't play in here. So when you're looking for total cost of the next 100, what we're looking for is the cost of 200 minus the cost of 100. So we already know what the cost of 100 is. It's here, and the cost of 200 is here. So all we have to do is really subtract them. So all that is the integral from 100 to 200 of c prime of x dx. So we don't have to include the initial value because we're going from 100 to 200. It is a net change that we're looking for. See, the first 100 include it. The next 100, it's just the cost of actually making those units. So just think about that first unit includes that 10,000. That's basically what we're talking about here. So all we have to do is 100 to 200 of 6q plus 1 dq and figure out what that is. So if you use your calculator or by hand, we get 90,100. All right, so that would be the cost of the first 100, and that would be the cost of the next 100 units. So the whole idea is if you're including the C0, you've got to include it here. See, even if we added over the C100, you'd have to actually calculate what C of 100 is. And C of 100 and 200 are both going to include that startup cost of 10,000. And you'll see why in the next one. So if we take the antiderivative, that's a q, of our 6q plus 1 dq, it's going to take us back, right, to our original function, which is the cost function. So the antiderivative of that would give us 3q squared plus q plus c. So remember, it's going to be 6 over 2, which is 3. And you notice we now have a constant thrown on there. So now, if you go back, we do have an original point, which is 6, c of 0, c0 is 10,000. So if we go c of 0, this would become 3, 0 squared plus 0 plus c. And then that equals 10,000. So we know that our 0 plus 0 plus c, so c is 10,000. So our actual cost function would be 3q squared plus q plus 10,000. So now if we do those exact same problems, we can find out everything we need. So we want to use the cost function to find the total cost of the first 100 units. Well, that is our cost function. So if we find c of 100, we get 3 100 squared plus 100 plus that initial 10,000, which this right here is this, right? That's our antiderivative, see, and we would have plugged in 100, and then we would have plugged in 0. So then all we're doing now is adding that C0 to it. So just so you could see this, this would have been 3 times 100 squared plus 100 minus 3 times 0 squared plus 0. So you can see that's what we have here. 3 times 100 squared plus 100 plus 10,000. Okay, so then this equals 40,100. So if we're going from 0, well, you're subtracting something that you had plugged 0 into, which would have canceled all those q's away, right? And it would have subtracted the 10,000 and 10,000 as well. So what we have to do is add that back in because there's initial cost. But what happens when you do the next 100? So the next 100 would be c of 200 minus c of 100. So we're just finding the total cost, right? The cost from 100. So plugging in 200 would give us everything from, it would give us the total cost from 0 to 200. And this would give us from 0 to 100. So if we subtract those, then the cost that we want right there from 100 would just be from 100 to 200. So it's a subtraction. By plugging in 200, it gives us a value. Plugging in 100, it gives us a value. And subtracting them tells us the difference between the two. So all we have to do now is plug in c of 100 and c of 200. So let's do c of 200, which would be 3 times 200 squared plus 200 plus 10,000. And then we also need c of 100, which we already did, but I just want to write it. So you can see, as we subtract these, what's canceling away? The 10,000. So we don't have to include it when we do the total cost. So we could just plug in c of 200 into our calculator, and it would give us 12,0200. And then if we plug c of 100 in our calculator, it gives us that 90,000. Or sorry, not 90,000, that's our answer. 30,100. And then subtracting them, we end up with 90,100, just like we did above. So you have options. You could honestly just find a cost function using this and then plug it in and subtract. But the integral is a lot quicker. Look at that. That was very little work, and we had to do 3 different situations here. Find the function and then plug in numbers and subtract, where you could just go through. Just remember that if you have 0, you're going to have to include that initial cost if there is a initial startup cost. So you can see it's the same thing.